Hello everyone, I am Sohom. Today I am here to present my research on demystifying financial texts using natural language processing. I did this work under the supervision of Dr. Sudip Kumar Noskar at Jadavpur University, India. Let me present to you some facts. Financial literacy refers to the art of managing money. Worldwide, only 1 out of 3 adults are financially literate. In India, the situation is even worse, with financial literacy of 27% only. If India has to become a developed nation, the per capita income needs to increase. On another note, the Indian Sensex has grown from 800 points to 80,000 points now. However, less than 3% Indians invest in stock market. Thus, we need financial education. In addition to this, many countries have a target of being carbon neutral soon. Thus, investments in the green sector have been increasing by leaps and bounds. Moreover, over the last few years, influencers and YouTubers have been alleged for market manipulation. Thus, investors need to be educated and they also need to be informed while making decisions. To deal with these, I present 5 themes which will make the investment process inclusive, improved, impactful, informed, and in-depth. Additionally, I present a few tools for analyzing financial texts. The overall objective is to improve financial literacy, reduce wealth disparity, and focus on sustainable future. This is expected to bring economic prosperity to the nation. Here is a summary of the entire work. Under the inclusive investing theme, I worked on improving the readability and reachability of financial text. Under the improved investing theme, I worked on detecting hypernyms and relationships between financial terms. Under the impactful, that is green investing, I worked on environmental, social, and governance, that is ESG, and sustainability related concepts, issues detection. Furthermore, I also worked on assessing ESG impact type and duration. Under the informed investing theme, I worked on detecting in-claim and exaggerated new models. Moreover, I worked on estimating profitability and loss from financial social media posts, deciding trustworthiness of social media posts by executives, and financial argument analysis. Finally, I worked on a financial text specific to India. So let me start the first theme, inclusive investing. It comprises 2 sub-themes, readability and reachability. Readability deals with how to quantify and improve readability of financial texts. Under this, I would like to present 3 datasets and tasks, namely financial readability assessment dataset, transfer learning based tool to assess readability of definitions of financial terms, or FinRead in short, and financial language simplifier. Reachability. Under reachability, I worked on generator guided estimation approach for a crowd reaction assessment framework. Financial readability assessment dataset, or a FinRAD in short, comprises 13,000 definitions of financial terms for measuring readability. It consists of financial terms, their definitions, and embeddings. We have manually assigned binary readability scores to the definitions and compared them with traditional rule-based scores. The manual scores were assigned based on the sources. Subsequently, we have developed a few neural baselines using transformer-based architectures to automatically classify these definitions as readable or not. We present a framework to estimate if a social media post will receive more reaction than the other. This is under the reachability piece. And for this, we introduce generator guided estimation approach, or the GGEA architecture. The GGEA architecture leverages large language models such as ChatGPT, FlanEval2, and Claude to enhance the predictions made by the classification models. The core component of GGEA is a fine-tuned Flang Roberta model which utilizes a cross-encoder architecture. The input is a concatenation of the texts from a given pair of text T1 and T2, and the response obtained from prompting Claude to elucidate why a particular tweet in a pair is more engaging. The expected output is whether T1 will receive more retweets than T2. To augment the usability during inference, we have employed an existing open source T5 based paraphraser with it. We present the task of hypernym, that is generic form detection of financial terms. There are 17 kinds of hypernyms. For an unknown term, we need to extract the corresponding hypernym. Now, all the hypernyms are not independent of each other. There was a hierarchy present, there is an hierarchy present among these hypernyms. We present this in the right hand side of the slide. The novelty of the approach we propose lies in developing an algorithm to create negative samples from this hierarchy. Finally, we use this to effectively fine-tune Finbert and FinISH embeddings. We ensembled cosine similarities from both the models to extract hypernym for a given unknown financial term. Next, we introduce the task of relation extraction in the financial domain. We introduce the mask one at a time MOAT framework for detecting the relationship between financial entities. For a given text having two entities, we mask one entity at a time, extract the contextual ACC BERT based embedding of the masked token separately. We used these embeddings with other engineered features to train a neural network based models having two hidden layers. This neural network based model classifies the relationship between the entities into one of the given categories. Under the impactful, that is green investing theme, we focus on how to ensure that investments that are made are towards betterment of the earth and have a positive impact towards the environment. We have worked on three kinds of problems: detecting ESG and sustainability related concepts, issues, and impact, assessing impact type, ESG impact type, and impact duration. Out of these, I would like to narrate the ESG impact type assessment in detail. ESG impact type assessment is a classification task given a financial text in either English, Chinese, Japanese, or French. We need to classify it into categories like opportunities, risk, and so on. Our approach comprises translation, marks language modeling, paraphrasing, and classification to identify ESG impact type across four languages. We used paraphrasers to augment minority class in the dataset, improving the model's performance on the skewed data distribution. This pipeline performed consistently well across all the languages, achieving top ranks in Chinese and Japanese subtasks. Under the informed investing theme, our target is to safeguard investor from misinformation. Our key focus is on detecting in-claim numerals, detecting exaggerated numerals in financial text, estimating profitability and loss from financial uh, text in social media, deciding trustworthiness of social media posts by executives, and financial argument analysis. We discuss a system for evaluating whether numerals present in financial texts are in claim or out of claim. It is an ensemble of three subsystems. The first two subsystems consist of fine-tuning pre-trained models, Finbert, and are almost identical. The third one is a logistic regression-based model built using contextual BERT embedding of the numerals and other engineered features. We introduced the task of deciding trustworthiness of social media posts by executives. In this work, we investigate the impact of social media posts, particularly from executives, on closing price of stocks and decentralized currencies. It integrates sentiment analysis from Twitter and Reddit with historical stock prices. Our findings are social media sentiment significantly influences stock prices. Executives posts by executives have a greater impact on the stock market prices than the general posts. As financial texts in Indian languages have not been studied much, we present three tasks for three most spoken Indian languages, Hindi, Bengali, and Telugu. In total, we released 9 datasets, and the tasks we focused are exaggerated numeral detection, sustainability assessment, ESG theme determination. Few samples are presented here. Finally, we present a financial language understandability enhancement toolkit, or Fluent in short, for processing financial text. It comprises 8 different tools which can be used for hypernym detection, numeral claim analysis, readability assessment, sustainability assessment, and so on. The objective of the tool is to empower masses and enable investors in making data driven decisions. This is open source under MIT license and is openly accessible. To recap, I worked on 14 tasks, created 7 datasets, 6 tools, and participated in 8 shared tasks till now. The languages I have worked on are English, Chinese, French, Japanese, Bengali, Hindi, and Telugu. I would like to extend my deepest gratitude to my supervisor, mentor, and collaborators for their invaluable guidance and support, as well as to ACM Sigayar for providing me the opportunity to present my research at CIKM. Here are my coordinates. Feel free to reach out if you have any questions. You can get a preprint of my paper by scanning this QR code. Thank you.